Good afternoon, student. So, we are studying science of class 9 and we are continue with a second chapter called force. So, this is our fourth class on it. So, yesterday we have studied about the equations of motions, isn't it? Yes, all of you, I think so. You have derived at home about the equations. So, what are the three equations yesterday we have derived? The first equation is V equals to U plus AT. This is the first equations of motion on accelerating body. Okay. So, in what type of problems we will use this equation, in which distance is not given among the four parameters. Among the four parameter, three parameter must be there, either initial velocity, accelerations or time. If these are known, then we can easily find out the final velocity. So, for finding out the final velocity on an accelerating body, we will use these equations. Yesterday we have done one problem also, and you have studied that one. The second equations what we have studied yesterday, the second equations that we derive as equal to ut plus half at square. U means initial velocity, time, acceleration. When time, acceleration and initial velocity is been given, so to finding out the distance covered by the body, that as is the distance covered by the body, we use this formula. That means, when initial velocity, accelerations and the time is given, at that times we will use this formula to calculate or the numerical problem. Then the third one what we have studied about velocity. V square equals to U square plus 2as. So, when time is not given, but initial velocity, accelerations and the distance cover is been given, and at that times we use this formula. So, what types of conditions this formula can be used? It is used for those body which are accelerating. Accelerating body, we use this formula. Means a body is moving with a uniform velocity or uniform acceleration, etc. And what types of numerical problems we will not use? It is not necessary to use this formula. Do you know in which types of problems we are not using these equations? Obviously, that is when the velocity is constant. That means, when the velocity V equals to U, then this equation is not needed. At that time, we directly can calculate as equals to velocity into time taken, or displacement equals to velocity or speed or into time taken. If it is distance, then speed into time taken. If it is displacement, vector quantity, then we have to use vector quantity. So, distance cover can be calculated with velocity into time. At what conditions? At the conditions when V equals to U, means that is the initial velocity and the final velocity is equal. At that time, we use this formula. Then again the next one. So, we are clear about this one. We have done one of the problem also. So, shall I go forward? Yes, that the next one where we applied applications. So, applications of these equations of motion in different situations. I already said that when the velocity is constant, velocity constant means what? Initial velocity equals to final velocity. If we will represent this one in graph, then what we will find? Suppose this is time, then this is v and u, the graph will be straight one, velocity upon time taken. So, this is the, is there any acceleration is been seen? No. At that time when the velocity is constant, at that time acceleration will be 0. So, at that time we can directly use the formula that for distance s equals to ut. Okay. Here either ut or vt, that is velocity into time taken. I think you are clear this one. So, when the velocity and initial velocity and final velocity is constant, at that time the acceleration of the body will be 0, and the time graph, if we will see this one, the velocity and the time graph, we will see a straight line. This is the velocity moving with a constant velocity. If the body is been accelerating, then the time graph will be like this, means increase in velocity with time, and that is the acceleration. Okay. So, next one, let us come to the next point, that is this we have calculated, or this we have derived from the horizontal moving body. Okay. Horizontally moving body like vehicles or the bus, jeep, truck or whatever, horizontally moving body, we calculate this one. But the velocity and the other thing is also happen when the body is moving vertically, when move from down to up or up to down. When a body move from lower part to higher parts and higher part to lower parts also, they cover the distance, they cover the high, means that is the have certain velocity, they have certain acceleration, and to means drop down to the ground they need some time. So, this formula, when they are the body is moving vertically, there is some change is been made in this formula. This formula is been practiced, but some change, that is the notations or denotions, the denoted object is been changed. So, the distance covered by the object at this one, we write what? We write s. Yes, when it covers the means distance, then it's we write s. But when it move from up to down, that is what? That is the height of the object. So, at that time when we are calculating the freely falling body under the gravity, then s will be denoted by h. H means what? And s means distance cover or a displacement. Height means straight line towards the ground. Then the next one is the acceleration. Accelerations means a. Yes, and the acceleration due to gravity you have studied in class 8. Acceleration due to gravity means that is also denoted, means the acceleration that is denoted by g. So, therefore, what will be the equation now? The same equation is that where there is written a, we have to write g, and where there is s, we have to write h. Okay. Yes, good. V equals to u plus what I have to write? Yes, very good. That is gt. Okay. The first equations, when the object is freely falling, then it will be u plus gt. Okay. Then the next one, next equation, s equals to ut plus half what? That will be half gt square, gt square, equation 2. Then comes to the next one. Next equation is, third equation is v square equals to u square plus 2 g s, number 3. third equation. And this equation is for what? This equation is for the freely falling object. Now, there are some of the things are been there. We means equation 1, 2 and 3 are written as like this when the object is been freely falling. Now, let us take one of the example, this. So, can you say what is the initial velocity of this object at this positions? What is the initial velocity? That will be, yes, that will be 0. Why? Because it is in rest. Okay. So, u equals to, in a freely falling object, u will be 0. Yes, u will be 0. And what will be the acceleration? The acceleration due to gravity is g, that is 9.8, or for our easier we can write 10 meter per second square. That is the a will be 9.8 meter per second square for the which types of body? For the freely falling body. So, it falls freely. Okay. Then the what will be the final velocity at that time? The final velocity is that what it drops to the down. So, can we write this one, this change in the numerical equations? If u will be 0 for the freely falling object, then the freely falling object directly we can write the formula what? We can write the formula v equals to gt. Can we write this one for the freely falling body? Yes, we can write s equals to u equals to how much? 0. This also 0. Then the equation will be what? S means that it will be the h. Okay, h. G h. So, h will be half g t square and v square equals to 2 g h. So, we can use directly this formula for the freely falling object, or we can write this one, because for the freely falling object the initial velocity will be what? That will be good. That will be 0. So, till there you are clear about the equation, I think so. Okay. For example, let us take one of the example, numerical example of it. A ball is falling freely towards the earth's surface towards the earth's surface it take 3 seconds, or we can 3 seconds to drop to the ground. What is the distance covered by it if its acceleration, it will not be written in your, although I make you clear, acceleration is equal to acceleration due to gravity. In your numerical problem, these conditions will not be given, but you have to make it mind that when the object is freely falling means initial velocity will be 0. So, given what? Given u equals to 0 meter per second. I am writing in short, u equals to initial velocity. You have to write in full in your solution. Then I only want to develop your concept regarding the numerical problems. U equals to 0 meter per second. Time, how much it is given? 3 seconds. Then acceleration, that is g. Freely falling means acceleration, that is g. Suppose we can take 10 meter per second for easier for our numerical problem. So, what we have to find out the distance covered, height equals to what? So, what are the formula here? V equals to g t, yes, h equals to u t plus half g t square, yes, v square equals to u square plus 2 g s. So, which formula is better for us? We have to find out height. Therefore, the second equations will be suitable for this numerical problem. Now, comes to the second numerical, that is equation, h equals to u t plus half g t square. According to the equations of motion, we have, according to equations of motions, we have h equals to u t plus half g t square. So, what is u here? U is 0 into t plus half, g means 10 into t means 3 square. 3 square. 0 into t is how much? 0 plus half means if we divide 2 by 10, then 5 into 3 3 is 9. So, h will be 45 meter. So, is there any necessary to write this one? Any necessary? No. Therefore, for the freely falling object, we can directly write half g t, h equals to half g t square. Okay. By writing this also, we can calculate one. Now, comes to the next one. This is for the which types of object? Yes, which type of object? That is freely falling object. So, if we have to find out velocity, then what we will do? What will be the which formula we will use it? That is what? V equals to u plus a t, or V equals to what? G t. Okay, we can find out the velocity also. Now, comes to the next one is the, if the body is been thrown upward. If the body is been thrown upward, when we throw upward a body, then what types of equations will be of motions? What types of equations we will have? So, in the vertical motions, we have written the formula V equals to u plus g t. Yes, one first equation. Second equation, s equals to u t plus half g t square. Second equation, we have written this one. Third equation, v square equals to u square plus 2a g s. Am I right? I think I am right, and you are also right on it. G h, sorry, it is written as. So, it is for the vertical moving object. Now, comes to the, when the object is thrown upward. When we throw upward this one, let us see, if I keep this one, it will move upwards? No. If I lift my hand, it will go downward, not upward. So, I need some force to throw upward like this, isn't it? So, the initial velocity will be what? Initial velocity will be the force that I lift the dusters. I lift the duster, that force will be the initial velocity. So, the object from point A, u meter per second, I throw upward, the object will be go upward, yes. And at the maximum height, what happened? At the maximum height, the v will be 0. It will be some few seconds at rest, because it will not go upward. Because why? Because it is been pulled by the gravity, acceleration due to gravity, it is been pulling downward. Therefore, it cannot go upward. So, at the maximum height it come to rest, again it fall down. Means the object will move upward and reach to a certain point, B point, and again it comes downward. Okay? It comes downward. Then what will be the distance covered by the object when it go to the maximum height and reach to the ground? How much? That is, it will reach double height and double time. Okay? That should be clear to you. Okay? Then the next thing, when we throw upward, then the accelerations produced in the body, because it is coming, finally it is coming into rest. That will be acceleration or retardations when it comes to rest. That will be retardation, that is the negative acceleration. When the body is being thrown upward, at that times the what happened, the object is being pulled towards downward. That means negative acceleration is acting on the object or the body. Therefore, what happened? What we have written for the freely falling object, the positive sign in the formula will be negative when it is been thrown upward, other things will remain same. So, what will be the formula then? It will be minus. Okay. This will be means the formula for which object? Which object? When an object is thrown upward. So, this will be the equations. So, these are the three things which you have to remember, that only when the object is freely fall, the equations will remain similar, but the only change is what? Only change is what? Only change is the the symbol of distance cover will change into height and accelerations into acceleration due to gravity. But when the object is thrown upward, at that time what happened? There will be change in the formula, that the positive sign before gt or the acceleration will be changed into negative acceleration minus a. That means g will be minus g for the upward going object. Okay. So, this is the sum of the equations. Now, what are the things to be remembered when we go to the numerical? The first one is what? Thing to remember. Thing to remember. Thing to remember. The first one is a body start from rest. If in a numerical problem, if you find that an object or the body or bus, vehicles or car, jeep, bicycle, whatever, it is been told that it start from rest, at that time what happened? U will always 0 meter per second. That means U is 0. Okay. The second point when a object body move or moving with a velocity, if a body moves or moving, that means that it gives numerical value of u, x meter per second. The value which is given in front of the moving object or the body, that will denote not the final velocity, that will be what? That will be the initial velocity u, that will be the u. Then the next one, a body, a brake is applied, brake is applied, okay. Brake is applied means what? That will be the final velocity will be what? Final final velocity v equals to what? V equals to 0 meter per second. And at that time what happened? At that time the accelerations will be what? That will be minus, that is retardation. Okay. So, when a brake is applied to a vehicle, at that time the velocity, the final velocity will be 0 and the accelerations will be negative acceleration. Then the next one, that will be the vertical moving object freely falling object, then u equals to 0 meter per second, okay, and accelerations will be a equals to g. Accelerations will be equals to g, meter per second square, okay. Then the next one, when it is been thrown upward, u equals to x meter per second square, x meter per second, and v equals to 0 meter per second. That will be the given velocity will be initial velocity, and the maximum height, the final velocity will be 0. 0 at what? At maximum height. And accelerations will be, or the g will be minus g meter per second square, because it is negative while we are throwing upward. And the time taken to fall, time taken to fall down, that will be 2t, okay. So, these are the some of the concept regarding the equations to do the numerical problems or the equations in our numerical problems. So, the numerical problems we will not practice over here because it will take time. So, you can practice your exercise at home, so that you can easily understand. If you use this thing, or if you remember this thing, you can easily do the numerical. And the another topic, that is inertia, okay. So, I will only somewhat tell you about inertia, and we will continue that one tomorrow. So, what is inertia? What the inertia means? How it defines? Means simply we can say that I have already tell you about the theory while motions, that is, it is the tendency or the property of the object, okay. It is the tendency or the property of the object to resist themselves, in the state of rest, motions, or any directions. means to resist themselves where they are. For example, if they are in rest, they will remain in rest until and unless any changes occur there. Okay? That is the tendency or the property of the object that lets them to rest in that position. So, that is called as the inertia, and in this chapter we are studying about the inertia of rest and motions. Okay? Inertia of rest and motion. So, what is inertia of rest? What is inertia of rest? That is, it is the state of, or the means it is the tendency or the property of the object to remain in the state of rest until and unless an external force is applied. Likewise, in motion also, the body will be continue, the tendency of the body will be continue in the state of motion until and unless an external force is applied on it. So, what is the relations with the inertia and mass? Inertia and mass. The inertia of the object is directly proportional to the mass of the object. Okay? Means symbol. If the means the mass is increased, then the inertia will increase. If the mass is decreased, then the inertia will be decreased. So, for today this much only. So, we will continue tomorrow. So, thank you to all of you and have a best time. Thank you.